Okay, you've been there. You've got material stacked up, the loader's waiting, and the screen is the thing slowing everything down. And you're thinking, why isn't there a machine that can just handle this without drama?
Well, there actually is. And today we're breaking down what it looks like when a screener is built to solve those exact headaches. Power, flow, safety, and uptime, all working together instead of against you.
If your operation pushes volume and you're tired of compromises, this episode is for you.
Welcome to the Lippmann Academy CrushCast, built for decision makers in high-volume, aggregate, mining, and recycling operations. Nick and Jessica share practical insight for those selecting crushing equipment, managing quarry and plant production, and driving uptime and efficiency across material processing fleets. If your work is about moving rock, maximizing tons per hour, and running safer, more profitable sites, this is your show. This podcast uses AI-generated voice and presentation technologies with human oversight at every stage. All content is developed, reviewed, and approved by Lippmann. The information in these episodes is intended for educational and informational purposes only and does not constitute professional or business advice. Let's get started.
Hello and welcome back to the Lippmann Academy CrushCast. I'm Jessica, your guide on the side of curiosity, here to ask the questions that I know are on your mind.
And I'm Nick, here to dig into the specs, the stats, and the engineering that makes these machines run. It is great to be back, Jess.
Nick, I have to be honest with you. I was looking at the product information sheet for the machine we are covering today, and my first reaction was just, whoa, wow, this thing looks absolutely massive. It looks less like a piece of equipment and more like a mobile processing plant. What exactly are we looking at today?
You are spot on, Jess. Today we're focusing on the Lippmann 624s-t, and you are right about the size. This is the largest mobile screener on the market.
The largest on the market. That is a bold claim.
It's a bold machine. The mission for today is to break down exactly what makes this unit such a beast. We're going to look at the volume it can handle, the sheer power under the hood, and the specific engineering features that separate it from the pack.
Okay.
Because when you're dealing with this much tonnage, size is just the beginning. You need the physics to back it up.
Okay, let's unpack this. When you say largest, just how big are we talking? Because looking at the photos, it just dominates the site.
It absolutely does. Let's start with the weight. The 624s-t tips the scales at 93,541 pounds.
Whoa, over 93,000 pounds. That is substantial. But Nick, playing devil's advocate here, is heavier always better, or does that just make it a nightmare to move?
That is the classic trade-off in engineering, right?
Uh-huh.
Mass usually equals stability, but it can kill mobility. However, this is where the engineering gets clever. Despite that massive structural weight, it is designed specifically for mobility. The transport dimensions are surprisingly tight for a machine of this class.
Oh, really?
Yeah, it's got a transport length of 66 feet 11 inches, a width of 12 feet 2 inches, and a height of 11 feet 10 inches.
So even though it's a giant when it's working, you can actually move it from site to site without a huge ordeal.
Exactly. It's built to move. You track it onto a lowboy and you're gone. But once you get it there and unfold it, it's all about the feed. You asked where the rock actually goes. It all starts at the hopper.
Right, the entry point. I see in the specs it has a massive opening.
It does. It comes with a 15-foot standard length hopper, and there's a 12-foot option available too. But just what's key here isn't just the length, it's the geometry. It has very steep hopper sides.
Why do the steep sides matter? Is that just to hold more rock?
It's actually about flow dynamics. In this industry, friction is the enemy. If you have shallow sides, material, especially if it's wet or sticky, tends to bridge. It sticks to the sides and creates a blockage.
Ah, so it stops the flow before you even start.
It stops everything from hitting the belt. Steep sides use gravity to ensure that material slides down immediately. You don't want material bridging or getting stuck.
That makes sense. Gravity is free energy. You might as well use it. And right at that feed point, I see listed something called the hydraulic tipping grid.
Yes, that is a feature that saves the operator a massive amount of headaches.
Walk me through a scenario where I'd use that.
Okay, picture this. You're feeding the machine with a large wheel loader. You dump a bucket of rock, but buried in that pile is a massive boulder, something way too big for the plant to process.
Okay.
It lands on the grid bars. On an older machine, you'd have to stop the plant, climb up there, maybe try to knock it off with the excavator bucket, which is risky.
Which sounds dangerous.
Extremely. With a hydraulic tipping grid, the operator uses the standard radio remote. They trigger the cycle, the entire grid lifts up hydraulically, the oversized boulder slides off the side, the grid resets, and they're back to screening.
So they don't even have to leave the cab.
No, they don't. It's all about uptime and safety. The remote also controls the tracks and the feeder, so you have full control from a safe distance.
That brings me to the power. You can't move 93,000 pounds and screen tons of rock with a standard engine. What is the heartbeat of this thing?
This is one of my favorite stats on this machine. It is powered by a Cat C 7.1 diesel engine.
And what kind of horsepower are we talking about?
It's putting out 225 horsepower.
Okay, for our listeners who might operate smaller screeners, that sounds like a lot of muscle. But again, does that translate to performance, or is it just burning more fuel?
It translates directly to torque. And we'll get into why that number is so critical later when we compare it to other machines. But essentially, it means you have consistent torque under load. Imagine you dump a heavy, wet load of clay-heavy soil into the hopper. A weaker engine will hear that load, and the RPMs will drop. It bogs down.
And when the conveyors slow down, your tons per hour drops.
Exactly. With 225 horsepower, the engine doesn't even blink. It powers through the surge. And Lippmann designed the engine compartment with large hinge access doors and a maintenance stand.
I love that. Accessibility is huge. If you can't reach it, you can't fix it.
Precisely. And speaking of reaching things safely, let's talk about crew safety. When you have a machine this powerful, keeping people safe is the #1 priority.
Absolutely. What specific safety features are built into the 624s-t?
It's a comprehensive package. First, you have 6 integrated emergency stops placed around the machine.
Okay, multiple points.
So if anything goes wrong, a belt tear, a noise that doesn't sound right, anyone standing nearby can shut it down instantly. Then you have a fully guarded working platform that wraps around the screen with integrated stairs.
So no climbing up makeshift ladders or walking on precarious ledges to check the screens?
Never. It's a proper workspace. They've also included external grease points.
Meaning
Your maintenance team can grease the bearings without having to reach their hands into dangerous moving areas. The lines are run to a central accessible block.
that is a detail that really matters on a daily basis. I also read something about anti-rollback devices. What is that?
That's on the conveyor. If you're moving heavy rock up an incline and the belt stops for any reason, maybe you hit an emergency stop, gravity wants to take over immediately.
Who wants to pull all that rock back down the slope?
Right, which would create a massive pileup at the bottom, or worse, an avalanche of rock. The anti-rollback devices stop the material in its tracks. It locks the belt so nothing slides backward.
That makes total sense. Okay, so we've got the size, the power, and the safety. But the name of the game is screening. It's a screener, after all. And looking at the diagrams, the screen box looks, well, different. It's not just one long flat sheet.
You've spotted the secret sauce, Jess? This is the split box design. It uses dual 6-foot by 12-foot triple-deck screen boxes.
Okay, Nick, break that down for me. Why split it? Why not just have one giant 6 by 24 box? Wouldn't that be simpler?
Simpler to build? Maybe. Better for screening? Absolutely not. There is some serious physics at play here. First, let's talk about mass and energy. If you build a single screen box that is 24 feet long, that is a massive, incredibly heavy piece of steel.
Right.
When you try to vibrate that huge, heavy box, a lot of the energy is just used up trying to flex and shake that steel structure. The steel absorbs the energy. By splitting it into 2 smaller 12-foot boxes, you reduce the structural mass of each unit.
So lighter boxes mean they're easier to shake?
Exactly. Because the boxes are lighter, more of the G-force energy goes into vibrating the material rather than just shaking the machine. You get a sharper, more aggressive screening action.
So you're getting more efficient vibration where it counts on the rock.
Exactly. But the real magic happens in the middle. We call it the central cascading area.
That sounds almost poetic. The central cascading area, what happens there?
Well, think about a deck of cards. If you slide a deck of cards across a table, the bottom card stays on the bottom, the top card stays on the top.
Right.
That happens on a long, flat screen. The small rocks might get trapped and just ride the raft of big rocks all the way to the end. But with the split box, as the material travels off the first 12-foot screen, it drops down to the second one. That drop causes the material to flip and roll over.
Ah, I see. So it breaks up that raft.
It reshuffles the deck. It gives that rock a new opportunity to find an open hole. It significantly increases your screening efficiency. It's all about stratification.
That is smart engineering. And I understand this also ties into the banana concept. I assume we aren't talking about fruit.
Not fruit, but shape. It's a dual slope configuration. Think of the profile. The feed end, The first box is steeper.
Why steep at the start?
To get the material moving. We call this thinning the bed depth. You have a thick pile when you dump it on, and you need velocity to spread that pile out so it's thin.
Great, so we spread it out fast, then what?
Then the discharge end, the second box, is flatter.
Because you want to slow it down.
Precisely. Once the bed is thin, you want to slow it down to give it maximum retention time. It allows for that final, precise separation. It's the best of both worlds. Fast clearing at the start, precise screening at the finish.
And I see here you can actually adjust the throw or the vibration intensity separately for each box.
Yes. Dual amplitudes. You can ramp up the throw on the first box to handle heavy, coarse material, really beat it up, and maybe dial it back on the second box for finesse. And here's a pro tip feature. Reversible throw.
Reversible throw. You can run it backwards.
You can reverse the rotation of the eccentric motors on the second screen. This actually pushes the material slightly uphill against the flow. It holds it on the screen just a little bit longer. If you're trying to meet a really strict spec on your fines, reversing the throw is a game changer.
That creates a massive amount of flexibility for the operator. Okay, so once the material is screened, it has to go somewhere. Let's talk about the conveyors.
It is huge. You have a 48-inch main conveyor and a 48-inch feeder conveyor. But look at the fines conveyor. It is 55 inches wide.
55 inches? That is wider than a sidewalk.
It's designed for high volume. The fines conveyor is usually the bottleneck because that's where the bulk of your material often ends up. A 55-inch belt eliminates that bottleneck, and it discharges at a height of 16 feet 4 inches.
Which means you can build a massive stockpile before you have to move the machine.
Exactly. And there's one more feature I have to mention. The integrated beater pulley.
The beater pulley. That sounds aggressive.
It's necessary. If you are working with sticky, material-damp soil, clay likes to stick to the belt. It creates carryback.
Which creates a mess and wears out rollers.
Right. The beater pulley is a slightly off-center roller that vibrates the return side of the belt. It literally knocks the sticky material off so it doesn't carry back.
It cleans itself as it works. I love that. Okay, Nick, this all sounds incredibly impressive, but I have to ask the hard question. There are a lot of screeners out there. Is the Lippmann 624s-t really that much different, or is it just bigger?
That is the ultimate question, Jess. Is it just big or is it better engineering?
Right, because buying a machine like this is a massive investment.
It is. And when we come back, I'm going to line up the 624s-t against the other leading machines in this class. We aren't going to name names, but we are going to look at the hard numbers. Horsepower, screening area, drive systems. And I'll tell you right now, when it comes to raw power, Lippmann isn't just winning. They are essentially doubling the competition.
Doubling. Okay, that is a claim we need to investigate. We are going to dive into those numbers right after this short pause. Don't go anywhere.
Every ton that goes through your plant starts at one place, the primary jaw. If it isn't flowing, nothing is. That's why Lippmann heavy-duty jaw dies are built to do more than just crush rock. Taller teeth, a more aggressive profile, and bigger gaps let fines pass through, keeping your chamber clear and your material moving. You get improved material flow, better product size out of the primary, and less slabby material heading to your cones and impactors. That means fewer blockages, less wear on the rest of your circuit, and more tons per hour where it counts. As the OEM, Lippmann designs these jaw dies to the same standards as our crushers, with lifting tools available for safer, faster changeouts and reduced downtime. Want lower cost per ton and long-term reliability from your primary crusher? Talk to your local dealer today and ask about Lippmann heavy-duty jaw profiles. Lippmann, legendary crushers, leading solutions.
Welcome back to the Lippmann Academy CrushCast. Now, let's rejoin Nick and Jessica as they continue the conversation.
Welcome back to the Lippmann Academy CrushCast. Before the break, Nick, you dropped a pretty serious teaser. You claim that the 624s-t has nearly double the power of its competitors. Explain yourself.
I stand by it, Jess. Let's look at the standard competitors in this large mobile screener space. Most of the other rock crushers and screeners you see out there are running a Cat C 4.4 engine.
And what kind of power does that put out?
Typically around 130 horsepower. Now, remember what I told you about the Lippmann. The Lippmann is running the Cat C 7.1 at 225 horsepower.
Exactly. 130 versus 225. That is a massive gap. It's nearly double the power output. But why does that extra 100-ish horsepower matter? Is it just for bragging rights? Does a screener really need that much?
It's not about bragging rights. It's about the application of torque. When you have 225 horsepower, it allows Lippmann to use a robust direct drive hydraulic system for the screens,
As opposed to what?
as opposed to belt drives, which are very common on competing equipment. On other machines, the engine spins a pulley, which uses a rubber belt to spin the screen box.
And what's the problem with belts?
Belt drives need a complicated tensioning system with constant maintenance to check belt tension, and they're susceptible to dust getting on the interface between the drive pulley and the belt. That reduces the friction needed to drive the system.
So now you're losing power before it even gets to the screen.
Exactly. That loss of friction leads to slippage, and slippage is energy loss. So instead of efficiently driving the screen, you're burning more energy. Your screening efficiency drops, and you end up with less clean product.
So the engine is running, but the screen isn't shaking hard enough.
Exactly. With the Lippmann 624s-t, that 225 horsepower engine drives hydraulic pumps that are directly coupled to the screen motors. It's a positive direct drive system with no slippage, just a direct transfer of power.
So under load, the other machines might start to bog down or slip, but the 624s-t just keeps eating.
It keeps eating. And it's not just the engine. Let's look at the actual screening area. This is another metric where the comparison really highlights the difference.
Okay, hit me with the numbers.
The standard other machines on the market typically offer about 330 square feet of total screening area across their decks.
330 square feet. Okay.
The Lippmann 624s-t offers 420 square feet.
Wow. That is almost 30% more screen to work with.
It's significantly more throughput capacity.
Yeah.
You're processing more tons per hour simply because you have more real estate for the rock to separate.
More power, more surface area. But I have to ask about the maintenance. I feel like changing out those screens could be a nightmare. Am I going to be out there with a wrench for 3 days?
That's a great question. Any operator listening knows the pain of rusted bolts on a screen deck. Lippmann thought of that too. They use a wedge-style tension system on the top and middle decks.
How does that work?
It eliminates the need for nuts and bolts on the tension rails. You simply knock a wedge out with a hammer, pull the screen, put the new one in, and knock the wedge back in to lock it.
So no searching for the right size wrench or cutting off rusted bolts with a torch?
No. It is fast, and it secures the media incredibly tightly, which prevents the screen cloth from flapping and wearing out prematurely.
So even the maintenance is designed for speed. Now, Nick, I want to pivot to something that is becoming more and more important: sustainability and fuel costs. Does this massive engine mean I'm just burning through my operating budget?
That is the perfect segue to talk about the dual power feature.
Dual power. So it's a hybrid.
In a sense, yes. The 624s-t offers a dual power option, where the machine comes equipped with an electric motor alongside the diesel engine.
How does that work in practice? Is it complicated to switch over?
Not at all. It's a simple switch on the control panel. You can connect the machine to line power, if you have it on site, or to a standalone generator set. You flip the switch to electric and you run.
And what are the benefits there? I mean, obviously you aren't burning diesel.
Right. First, direct cost savings. Kilowatt hours are often cheaper than gallons of diesel. Second, maintenance. If you run on electric, you aren't putting hours on that Cat C engine.
Which means fewer oil changes and a higher resale value.
Exactly. And I assume that helps with permitting too.
Huge help. In some areas, getting an air permit for a diesel engine is difficult or impossible. If you can run on electric line power, you bypass that issue entirely. Zero local emissions. But do you lose performance? I feel like people worry that electric means weaker.
Not with this setup. Because it utilizes 90% of the same hydraulic components, the performance is identical. You're just changing the source of the energy that spins the hydraulic pumps.
That is fantastic. You get the flexibility of diesel for remote sites, but the option for electric when you're set up for the long haul.
Exactly. It's about future-proofing your operation.
Well, Nick, we have covered a lot of ground today. If you had to summarize the product information for our listeners, what are the 3 things they need to take away?
It boils down to this. First, power. That Cat C 7.1 engine, giving you 225 horsepower, provides the torque for direct drive hydraulics. Second, volume. You have 420 square feet of screening area compared to the industry standard of 330. And third, smart design. The split box with the cascade effect and the option for dual power makes it a machine that isn't just big, it's intelligent.
Exactly. When you need volume, you need size. But as we learned today, you also need the engineering to back it up so that size works for you, not against you. The Lippmann 624s-t seems to have plenty of both.
It certainly does. It's built to dominate the stockpile.
And so, if you're listening today and saying, I need that kind of capacity on my site, here is what you need to do. You can contact a dealer directly from the network. You can find them at lippmanncrushers.com. That is Lippmann, Lippmann crushers.com.
And if you want to see the numbers yourself, the belt speeds, the transport heights, all of it, check the link in the show notes. We've got the full spec sheet waiting for you there.
And of course, if you enjoyed this breakdown, make sure you download, subscribe, and share the Lippmann Academy CrushCast. We don't want you to miss an episode.
Thanks for listening, everyone.
Go crush it. We'll see you next time.
Thanks for joining us on the Lippmann Academy CrushCast with Nick and Jessica. To explore more insights, catch new episodes, or learn how Lippmann is helping customers run smarter, safer, and more productive operations, visit lippmanncrushers.com and follow Lippmann Academy online. We appreciate you listening. See you next time.